Hi, I'm Paul. Welcome back for another Blazor brief. Recently I was asked how I configure and use gRPC code first in my Blazor WebAssembly applications, so I thought I would make a short video showing exactly how I do this. As a side note, it's exactly the same as I have done since Blazor.net 6 and is how I will continue going forward in Blazor.net 9. I am sure you have heard of and maybe used gRPC services in your applications. If the code first bit is new, it just means that we can create the service definitions directly in C#, not dissimilar to how we did things in WCF. So instead of using proto files and code generation, we just write everything in C#. For applications I write where I have full control of both the front and back end. This is perfect. The demo is a bit lackluster, but I have used the bare minimum of code just so you can concentrate on the setup, which we will look at after the quick demo. All the code is on GitHub to download, with the link to the repository in the video description below. When we click the button, it will call the gRPC service on the backend server hosting project, which is hard-coded to return a list of customer search results with a single entry. Nothing special, but it will show how to pass data to and get data back from a gRPC service, the whole point of the brief. The very first time we click the button, the DI container will set up a gRPC channel using the settings provided that will be used to communicate with the server. The channel is then used to create the service client capable of using the code first gRPC services. So the very first time we try to communicate with the server, there may be a few milliseconds delay while the channel is being configured, after which it's pretty instant. I will click the button and there will be a slight delay before the result is written to screen. As the code just overwrites the list, I added another button that clears the list so it's clear that the service is being called to get the data. Let's clear the list and call the service again. This time there is no noticeable delay. As the channel is now configured in the DI container, we can move around the site, come back and call the service again without experiencing the initial delay. Now that the spectacular demo is over, let's see how it was done. First, the solution structure. For this brief, I used the Visual Studio Blazor web app project template, selecting the interactive render mode of WebAssembly with the location of global, so we get both the server hosting project and the client-side application. After this, I then added a C# class library project to the solution named contracts for all of the classes and interfaces that will be shared by the other projects, adding references from the server hosting and client-side project to the contracts project. Let's start with the contracts project, as both the server and client projects references this code. The first thing to note is that we will need to add the NuGet package called protobuf-net.grpc, as we will need to access some of the attributes in order to decorate our classes to define our services and data class members. In the customers folder we have three files. The customer search result record class is what we want to consume in our UI. I used a record class simply for its toString method for its pretty printing of the properties. The first thing to note is that for the binary serialization to work, just like using proto files, we need to specify a field number in order to map the property to its location in the serialized message in order for it to be deserialized. When using gRPC code first, you can use the WCF style data contract and data member attributes, but I would advise to always use the proto contract and proto member attributes like the sample code to have finer grained control over the serialization process if need be. The next file is the customer messages. This is where I would put all of the classes used by the gRPC service for both requests and responses. If you have not used gRPC before, you cannot just pass primitives, you have to pass and receive classes, or in protobuf terminology, messages, hence my file name of customer messages. I tend to always suffix my return classes with response, and for those classes, unless I am returning just a single value, I tend to use the response class as a wrapper that contains inner classes in its property values. Even with a single value, I still might wrap that value in a class. I find doing this just gives me a bit more flexibility in how I do things, as well as being able to add additional data in the response class regarding the actual data without the need of using gRPC metadata entries or altering the data class. For the classes that form requests, for simple queries I will just use properties containing primitives. But when I say make a request to the server to have new records created, I will use the request class as a wrapper, again using classes for its property values. Although I always suffix my classes with response, I generally do not add a request suffix for requests, but have done so here just to make it clearer for you. Thinking about it, maybe I should do this, as it does make things explicit for others new to the project. As you can see, we have a customer search request class and its corresponding response. In this instance, the customer search request just has a single string parameter for the search criteria. In reality, this is likely to have more fields, or just a property holding a class such as search criteria, whatever makes sense for your application. Just remember that any classes involved in gRPC serialization need to have the appropriate attributes added. Next is the interface definition for our customer service iGRPC customer service. As you can see, it's extremely similar to WCF. Instead of the attributes service contract and operation contract used by WCF, we have service and operation for code first gRPC. The operation defined takes as a parameter a customer search request and returns a customer search response. The call context is something that I always add, even though I have not had a need to use it. This allows you to pass metadata from the client to the server. If you use tokens, this is where you would put them, or you can add deadlines to cancel service operations after a certain amount of time, etc. As a side note regarding authentication and authorization, I predominantly use cookies in my Blazor WebAssembly applications, as I tend to work with single domains. I can tell you that in Blazor you do not need to do anything special to have cookies work with gRPC other than the usual setup of the authentication state provider, i.e. I have never had to do anything special in my gRPC services in order to be able to use both authorization attributes and policies on the ASP.NET backend. Now we have our service defined and the messages aka classes for requests and responses, let's turn our attention to how this is implemented on the server. For the server project, we need to add two NuGet packages, protobuf-net.grpc.asp.NET Core and grpc.asp.NET Core.web. The protobuf-net.grpc.asp.NET Core package is for gRPC code first development. The grpc.asp.NET Core.web package allows Blazor WebAssembly to use gRPC services over HTTP 1.1 by translating gRPC web requests compatible with HTTP 1.1 into standard gRPC calls, which natively use HTTP 2. In the gRPC services folder, we have an implementation of the iGRPC customer service interface. In order to concentrate only on the gRPC stuff, I have just hard-coded the response message. In reality, you would probably just use an injected DB context to access a database or call some query handler, etc. After the service implementation, we will then update our program file in order to be able to access the service. First, as seen on line 17, we had a service that can handle code first services, and in this instance I have specified the option to use optimal compression. Then on line 51 we use app.use gRPC web for the translation of HTTP 1.1 to HTTP 2. Then on line 53 we use app.map gRPC service to set up an endpoint for our service, and with that we are done with the server. Finally we get to our Blazor client project. We need to add two NuGet packages, grpc.net.client.web and grpc.net.client. The grpc.net.client package provides the core functionality to create a .NET client for interacting with a gRPC service via a channel, and the grpc.net.client.web package enables support for gRPC web, allowing Blazor to communicate with the service using the web-compatible protocol. There are different approaches to how the service is accessed, so to get you started I will show you the way that I have done this for the last 4 years without any issue. First I create what I would normally for accessing data, a service, adding the appropriate method signatures. I then use this as an adapter or wrapper, whatever term you prefer, to call methods on my gRPC service. I configure the DI container so I can have the channel injected into my service and then use the channel in the constructor to create the client for the service, and that's it. You can of course do this differently, but I find this way keeps things nice and neat. After this we just need to update our program file to register our service, and as mentioned I like to configure the channel and have that channel available for injection. On line 14 we retrieve the base address of the Blazor server application using builder.hostenvironment.base address. On line 18 we configure the gRPC channel by setting the server's base URL and specifying the channel options. Specifically, we use a gRPC web handler to ensure that Blazor can communicate with the server over HTTP 1.1, since browsers don't natively support HTTP 2 for gRPC. This handler allows gRPC requests to be compatible with the web by translating them into the gRPC web protocol. On line 26 we then just register our customer service. Finally, code on the home page requests a service via the @inject directive that our button click event handler customer search makes use of. The only thing I should point out is that I have disabled global pre-rendering on the project, as otherwise when requesting the home page, pre-rendering on the server would have failed, as the server hosting project does not have a customer service registered like the client project does. There are various ways to handle this situation if pre-rendering is required for the page with the service, but that's probably best left for another brief. That's it for this Blazor brief, but as always feel free to add good or bad comments and I will try to answer any questions raised. Until next time, bye for now.